Welcome back to zeros of polynomial functions, and we'll look at multiplicity of those zeros. Okay, think with me for a few minutes. What on earth is a zero? Well, we've got to define it. It either means y is 0 or x is 0. So when we define zeros, we're talking about the x that we find to go with y equals 0. So we plug in 0 for y when we talk about a 0 and find x. Well, let's look back at our y equals x squared and y equals x cubed graphs. Looking at our graphs, we can get some ideas here about multiplicity. Notice that y equals x squared turns up after it hits the axis down here. Let's see what's going on. If I put in 0 for y, which is what it means to be a 0, and factor the right side, I would get x equals 0 twice. So we say x equals 0 occurs twice, therefore we have multiplicity 2. And notice when we have multiplicity 2, the graph hits the axis and turns back. Looking at y equals x cubed, plugging in 0 for y, we get x used 3 times when we see x cubed. So we get x equals 0 3 times. So we say this is multiplicity 3. So right here we have an odd multiplicity, and we notice that we go through the axis rather than turning around like we did in y equals x squared. So every time we have odd multiplicity, it will follow the pattern of y equals x cubed of going straight through the axis. But on the other hand, when we had multiplicity 2, our multiplicity was even, and when it's of even multiplicity, we will hit the graph at that 0 but turn back around. So let's see if we can do some multiplicities here of our zeros after we find them. Looking at this problem, find the zeros and state the multiplicity for each. State whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. Well, they were real nice to us. They gave it to us in factored form. So if I write down 0 for my y equals 4 times x plus 3 times x plus 5 used twice, and then let each factor with an x equal 0, I get x plus 3 equals 0, x plus 5 equals 0, x plus 5 equals 0. Subtracting 3 from both sides, I get x equals negative 3. Subtracting 5 from both sides here, I get x equals negative 5. Subtracting 5 here, I get x equals negative 5. Now, it may worry some of you that I didn't let all the factors equal 0. So if that's worrying you, I can let 4 equal 0, but I know that's false. So that didn't find me an x, plus it made a false statement. So you can go through that step if you want to convince yourself that you don't need that. But getting back to our answers, how many times do we have this answer? 1 time. So the multiplicity 1 is what we have, or your homework program may ask for odd multiplicity. Whichever way it states it, you can give it to it, either 1 or odd. That means it goes through the axis, crosses the x-axis. So let's write that down, crosses x-axis. Right here, we have negative 5 twice, so the multiplicity is 2. And it is an even multiplicity. So that means it touches the x-axis and turns around. touches x-axis and turns around. Goes back the way it came. So that will be useful information to us when we get ready to graph. So let's practice one more here. Find the zeros and state the multiplicity for each. State whether the graph crosses the x-axis. All right, if it crosses, remember that would mean that it's odd multiplicity. So we'll write ourselves a note. And if it touches the x-axis and turns around, it has even multiplicity. All right, if I let x plus 1/3 equal 0, I get x equals negative 1/3. If I let x minus 5 equal 0, I get x equals 5. Now, I could have written that factor out 3 times, but I think we kind of get the picture now that this is occurring 3 times. So x equals 5 has multiplicity 3, or odd multiplicity. X equals negative 1/3 occurs just once, so its multiplicity is 1, or it is also odd multiplicity. So what does that mean? For odd multiplicity, both of these cross the x-axis, goes right on through it, rather than turning around. All right, that's all for this section, and we'll get back later.